to my channel. Today we'll be talking about equations of motion, and we know we actually have three equations of motion, whereby the first equation is V. We have V equals u plus at. This is the first equation of motion. V equals to u plus at. Let's make this equation 1. Then another one is S equals ut plus half at square plus half at square. Now if we have this is equation 2, and the third one is, the third equation of motion is v square equals u square plus 2as plus 2as. So this is the third equation of motion. So now let's see how these equations have been derived. So the first thing to do is we're going to look at the first one, and the first one, which is this. Now the first one goes to be, if you recall, acceleration is the rate of change of velocity. So if acceleration equals v over t. So don't forget, it's the rate of change of velocity, meaning that the change of velocity is involved. So if we have this kind of condition, then the change of velocity involves two things, which means final velocity minus what? Initial velocity. So we are going to symbolize this as A equals final velocity is v minus initial velocity, which is u, over what? T. So if this is obtained, what do? We cross multiply. Once we cross multiply, this will be v minus u equals 80. So if I have v minus u equals 80, then the next thing I'll do is, how do I take u to the right hand side? I'll come here and switch this minus u coming down to this place. Of course, it will be plus u. So it will be v. This gives you v equals u plus 80. This gives you what? V equals what? U plus 80. So this is the first equation of what? Motion. So this is the first equation of motion. Now the next phase is proving the second equation of motion. So I have successfully achieved this. For the second equation of motion, recall that the second equation is given as S equals ut plus half at squared. So if I have this kind of condition, it means that I can come here and say that if S equals ut plus half at squared, this is exactly what I want to prove. So the first thing that comes to my mind is, how do I proceed about this? We know that there's something called average velocity. When you take an average of 2 points, it means that you are actually getting the final and the initial being added together. You are dividing by what? 2. I want to get the average of 2 boys. Now the average age of 2 boys, one is 13, the other one is 15. I take 13 plus 15, I add it together, divide by 2, which is 28 over 2, and that's 14. That's their average age for the 2 boys. So the average velocity here stands to be, I'll make this v half. If I make this v average, this gives me v plus u over what? 2. So this is a clear example of what? Average velocity. But we know that we have this as average velocity. We know that distance s equals vt. You know, there are some terminologies that seems to be different from math. For instance, we know that For maths, it is distance equals to speed times time. And usually what we used to know then could be distance equals to st. But in this case, we are working with s equals vt, where s is standing for the distance, v is the velocity, which is representing the speed, and of course t has always been constant for many conditions. So what do? This is average velocity in here. So the next thing I'll do, I'll just simply say s equals, I'll substitute the whole of this into this. S equals v plus u over 2. Don't forget that there is a t involved. I'll close this bracket and put a t here. So I'm progressing. The next thing I'll do is, if you recall from our first equation of motion states that v equals to u plus what? At. V equals to u plus at, first equation. If I substitute this v in place of this v right here, that makes it so easy. Rather, I substitute it in place of this v here. So that makes it so easy. So that becomes s equals u plus at plus u over 2. Then I am still closing the brackets and a t is outside. Can you see this? So this is s equals to u plus at plus u over 2. Now recall we have two u's. So if we add those two u's together, that's s equals 2u plus at over 2, close this bracket again, times what? T. Times what? T. So I've successfully solved the equation to this point. So the next thing I'll do here is, I'll look at it so closely, I'll say the next thing is, I can use t to multiply into the bracket. So that gives s equals 2ut, t goes into the bracket, plus a t times t gives you at squared. I have at squared, then over what? 2. So eventually, then I can spill this t into 2, which gives s equals 2ut over 2. Then I have plus at squared over 2. So this gives at squared over 2. So if I have this, it makes it beautiful. So the next thing I'll do is, this spills this. So I'm left with s, which is the distance, equals ut. Don't forget, there's a slight one which you can't see, which lies here. That's the one that's a coefficient to at squared. So if you have that, that's ut plus half at squared. So ut plus what? Half at squared. I successfully proved the second equation of what? Motion. So that is the second equation of motion. So let's look at the third one. The third one is the last equation of motion. So if I look at that third equation of motion, then what I'll just simply do is, coming to this place, I'll see that for the third equation of motion, we have it as v squared equals u squared plus 2as. So how do we arrive to this? Let's go with our simple logic. The first thing you do, you generate the first equation of motion. Don't forget that the first equation of motion is v equals u plus at. So if I have v equals u plus at, what do? I square both sides of the equation. Squaring both sides of the equation, this gives me v squared equals u plus at squared. So if I have this, it means that I can put this in two places. So that gives you a v square equals, this is u plus at then another u plus at. This is a u, not v. Another u plus at. So in this case, that means v square equals u times u gives you what? U square. Plus you have u times at gives you u80. So 80 times u gives you another what? u80. You have another plus u80 again. u80. Then plus the last one is 80 times 80 gives you what? A square t square. So now that this has been generated, what do? You sum up u80 and u80 together because they lie in between the equation on the right hand side. So that's v square equals u square plus u80 plus u80 gives you what? 2u80. So if you have 2u80, then the next one is what? Plus a square and t square. So if I have v square equals u square plus 2u80 plus a square t square, then it means that I can factorize 2a on the right hand side. If I factorize 2a on the right hand side, this gives you v square equals u square plus 2a into brackets. Then you have ut here plus, then of course you have half a t squared. Now this is the logic. If you look at that right hand side, you see that if I come to this place, you observe that if I multiply 2a by ut, it gives me exactly 2u 80. Then plus, if I multiply 2a by half at square, 2a by half at square, then it means that this cancels this. Then you have a times a, which gives you a square. So that's how we came about that section. But if you recall very clearly, s from our previous equation, s equals ut plus half at square. So coming back to this, I can replace the whole of what I have in the bracket with s. So eventually this is v square equals u square plus 2as. So thank you very much, guys. We just successfully proved the 3 equations of motion. Thank you so much. Don't forget to subscribe, like, and join us in this section of the class. See you in my next class. Bye.